Hello everyone. Now we are going to discuss about construction and working principle of microwave T-junction. There are three types of T-junctions are there. One is E-plane T, second one is H-plane T, and third one is magic T. And these T-junctions are mainly used to split or combine the microwave signals. An E-plane T-junction is formed by attaching a secondary waveguide along the broader dimension of the main waveguide. Main waveguide has two ports. These ports are called as collinear ports. The secondary waveguide port is called as side arm or E arm. This E plane T also called as series T. As the axis of the side arm is parallel to the electric field, this junction is called as E plane T junction. The port 1 and port 2 are 180-degree out of phase. That means if any signal felt at port 3 can be divided equal in magnitude, opposite in phase among port 1 and port 2. As the E-plane T junction is having three ports, so the scattering matrix having the dimension of 3 cross 3. So now we need to derive the coefficients of the scattering matrix. Initially, consider that the scattering coefficient S12, S13 and S23 are out of phase by 180-degree phase with the input ports. So we can able to write S23 equal to minus S13. Since the ports are perfectly matched, S33 equal to 0. Then by using the symmetry property, we can able to write Sij equal to Sji. That means we can write S12 equal to S21. Similarly, S13 equal to S131 and S33 equal to 0. In E-plane T, the output ports port 1 and port 2 are out of phase by 180 with respect to input port 3. Then the scattering coefficients can be written as S32 equal to S23 is equal to minus S13. Then considering the equation 2, 3 and 4, the initial scattering matrix can be written as shown in equation number 5. By the statement of unitary property, the product of scattering matrix with the complex conjugate of same matrix is equal to unitary matrix. That means diagonal elements will be having value as 1. Then by multiplying row 1 and column 1, we can able to get equation number 6. Similarly, by multiplying row 2 with the column 2, we can able to get equation number 7. Then by multiplying row 3 with the column 3, we can able to get equation number 8. Then multiplying row 3 with the column 1, we can able to get equation number 9. Then by comparing equation 6 and 7, we can able to get S11 equal to S22, which is shown in equation number 10. From equation number 8, we can able to get 2 into S1 square equal to 1. From that S13 equal to 1 by root 2. From equation number 9, we can write S13 into S11 star minus S21 star equal to 0. From that, S13 is not equal to 0. So, there might be S11 star minus S12 star is equal to 0. From that, we can able to get S11 is equal to S12, which is equal to S22 by substituting equation number 10, 11, 12 in equation 6, then we can able to get S11 is equal to 1 by 2. Substitute all the obtained values in the initial scattering matrix so that we can able to get final scattering matrix. B equal to S into A, where B is the output coefficients, S is the scattering matrix, A is the input coefficients. H-plane T-junction is constructed by attaching the secondary waveguide along the narrow dimension of the main waveguide. The ports 1 and 2, which lies in the main waveguide, is called as collinear ports. The side port is called as H-arm or also called as shunt arm. As the axis of the side arm is parallel to the magnetic field, this T-junction is called as H-plane T-junction. Similar to E-plane T, H-plane T also are having three ports. So the scattering matrix will be having the dimension of 3 cross 3, and also any signal fed at port 3 is divided equal among port 1 and port 2 equal in magnitude and with the same phase, so that we can able to write S12 equal to S13. Then from the property of symmetry, we can able to write Sij equal to Sji. So we can able to write S12 equal to S21, S23 equal to S32, and S13 equal to S31 as shown in equation number 1. Since the port 3 is perfectly matched, then there is no reflection at port 3. So S33 equal to 0. Now the scattering matrix can be written as shown in equation number 2. From the unitary property of scattering matrix, the product of scattering matrix with its complex conjugate is equal to unitary matrix. Then by multiplying row 1 with the column 1, we can able to get equation number 5. Similarly, by multiplying row 2 with the column 2, we can able to get equation number 4. Then multiplying row 3 with the column 3, the equation number 5 is obtained. Finally, the product of row 3 with the column 1 will yield you equation number 6. Then from equation number 5, we can able to write 2 into S13 whole square equal to 1. From that, S13 equal to 1 by root 2 as shown in equation number 7. By comparing equation 3 and 4, we can write S11 whole square is equal to S22 whole square. From that, S11 equal to S22 as shown in equation number 8. From equation number 6, S13 into S11 star plus S12 star is equal to 0, so that S13 is not equal to 0. Then only possible thing is S11 star plus S12 star is equal to 0. From that we can able to obtain S11 star equal to minus S12 star as shown in equation number 7. Then from equation number 9 we can able to write S11 is equal to minus S12 or minus S11 is equal to S12 as shown in equation number 10. By substituting equation 10 in equation 3, we can able to write S11 square plus S11 square plus 1 by 2 equal to 1. Then 2 into S11 square equal to 1 by 2. From that S11 equal to 1 by 2 as shown in equation number 11. Then by using equation number 10, S12 equal to minus 1 by 2 as shown in equation 12. S22 equal to S12 as shown in equation number 13. By substituting S11, S12, S13 and S22 values in the initial scattering matrix, we can able to get the numerical values of the scattering coefficients of the H plane T. Magic Tea, also called as hybrid tea, which has four ports. The hybrid tea can be obtained by joining the two secondary waveguides along one is along the broader dimension of the primary waveguide and another one is along the narrow dimension of the secondary waveguide. So it has four ports. Port 1 and port 2 lies in the main waveguide. Port 3 is also called as H arm or sum arm, and port 4 is called as E arm or difference arm. If a signal having equal magnitude, same phase is fed at port 1 and port 2 means that signal will be added and you will get the added sum of output at port 3 and 0 output at port 4. Similarly, if a signal sent at port 4 will be divided equal magnitude and opposite phase among port 1 and port 2 and there is no signal at port 3, hence we can able to write S34 equal to 0. Similarly, any signal fed at port 3 will be divided equal in magnitude same phase among port 1 and port 2 where there is no signal output at port 4, hence we can able to write S43 equal to 0. If a signal is fed at one of the collinear ports will not appear at the another collinear port. So we can able to write S12 equal to S21 equal to 0. As the magic key is having four ports, The scattering matrix of the magic key will be having the dimension of 4 cross 4. Then by using the sum of the properties like any signal fed at collinear port will not appear at the another arm of the collinear port. So we can able to write S21 is equal to S12 equal to 0. Similarly, port 3 and port 4 are highly isolated ports. That means there is no coupling between port 3 and port 4. So we can able to write S34 equal to S43 equal to 0. Then by substituting these values in the initial scattering matrix, we can able to get the coefficients of the scattering matrix of magic T. The three important applications of magic T are magic T mainly used in impedance measurement and also used as a duplexer and as a mixer. In impedance measurement circuit, a null detector is connected to E port and a microwave signal source is connected to H port. The collinear ports together with the secondary ports will act as a four arms of the bridge, and impedance measurement can be done by balancing the bridge. In the second application, the magic T can be used as a duplexer. Duplexer is a circuit which works as both a transmitter and receiver using single antenna. Port 1 and port 2 are used as a receiver and transmitter were isolated, hence there will not be any interference. E-plane T as a mixer. E arm is connected to antenna and H arm is connected to the local oscillator. So port 2 has matched load with no reflections and port 1 has the mixer circuit, so that we can able to get the intermediate signal frequency.